Hello everybody. Today we're going to be looking at how we can expand algebraic expressions with single brackets. I'm sure you could find a lot of videos that basically show you how to do this, but I really think that it's important for us to understand how this actually works so it makes more relevant sense. And I'm going to make a nice little attempt in allowing you to do a more in-depth, to have a little more in-depth understanding of why we do this, how this works, and I would like to give you options as well when it comes to doing an expansion of an expression with a single bracket. Now, before we do that, let's do a bit of a little recap first. Okay? Now, so let's talk about what an algebraic expression is. Now, an algebraic expression is where you have a few terms that you would like to put them together. So in algebra, we know that we do use alphabet letters very frequently in place of numbers. So we do know that instead of saying a number, we could say something like X, or we could use things like Y, and we could even think about maybe we could start looking at maybe adding these terms up, or even subtracting these alphabet letters, or even multiplying them or dividing them as well. So give you an example here. If I have an expression, let's say I have a term, let's call this X. Okay? Now, if you have just X itself, this is also considered as an expression. Now, another example that I could be looking at would be, I could have like X plus Y. Just adding these two. You might say that, what is X? What is Y? Does it really have to represent something? Now, we don't really have to replace X or Y with a number because algebra allows us to be as abstract as possible. Of course, we do like to have numbers because that's what we're so used to, but it's technically very fine in algebra to have a letter added to another alphabet letter, which is absolutely fine. We could obviously substitute these letters with numbers, so that we could get an actual answer. But in this case, we don't have to, because algebra allows us to be as abstract as possible. Of course, we could have something like A plus B plus B plus B, which we know that this is basically 2A, and this is 3B. This is also considered as an algebraic expression. So basically, in a nutshell, any operations that you could do when it comes to addition, subtraction with letters, that will be considered as an expression. Okay? Now, so today what we're going to be doing is we're going to look at how we can actually do multiplication, all right, of a number or an alphabet letter to an algebraic expression. So this is really what we are aiming to do in today's class. We will learn how to do an expansion of an expression with... Now, the thing is about when I say brackets, let me just show you how this works. We're going to multiply an expression to a number or letter. Okay, so this is how it's going to look like. So we can take we're going to learn how to do 5 multiply by an expression. Let's call the expression A plus 4. Okay, or usually we don't write this with the multiplication sign. We actually write it with the brackets in this case, because these two basically mean the same thing. Okay, it's just a very you might say it's just a more fanciful way. Both means the same thing. There's nothing wrong in writing 5 times A plus 4 or 5 bracket A plus 4, which generally mean the same thing. Now, so what does this basically actually all mean? Because it's so abstract, isn't it? Like, why do we have to even learn how to do these kind of multiplication in this case? Now, I want to show you a nice little example here. I'm going to draw a little rectangle here. Okay, we're going to start looking at how rectangles generally work in nature when it comes to finding the area. Now, let's say if I'm going to give you this length to be 8, this to be 5. Now we know that the area is basically just taking 8 times 5. That gives me 40. With numbers, that's easy. Obviously, we learned this back in the primary school, or even way before primary school. Some of you may have even learned how to find the areas, right? But what if we make this a little more abstract? All right, let me just change the color here, just to kind of really differentiate the difference between the two concepts here. Now, let me just change all the numbers up. Instead of 8, I'm going to call this a plus 3. And I'm going to call the breadth of the rectangle to be, let's say, 4. Now, you might say, how can the length be a plus 3? Now, like we said, a could be any number, right? If we put a to be 5, then the length of the rectangle is going to be 8. But in this case, like I say, I'm just going to let the length of the rectangle to be as abstract as possible, because that would generate multiple possibilities on what the length could be. But I'm just going to call this a plus 3. Now, so how do we find the area? Now, does the area need to be in the form of a number? No, of course it's not going to be a number, because we got a as a term in one of our lengths. So it is expected that the area will have a in it. So the area, if we write this in algebra, we can actually write this as a plus 3. Now, do you realize something that I always do with the a plus 3? And if you look at the objective that I written earlier, is that if I have two terms, which is a, and the other term could be a number, and when I add them together, I usually put a bracket to this, okay? And I'll show you why it's not right not to put the brackets. Now, we know that the area is just going to take a plus 3 multiplied by 4, okay? Or we could also write it like this, 4 times a plus 3. And of course, like I said, you don't even need to put the multiplication sign. We can actually write it like this. All 3 would be acceptable. But what is not acceptable would look something like this. And some of you might be very guilty of doing this in the foreseeable future. Okay, so I'm going to put a little cross here. Oops, did I not choose black? Okay, what you should not do, okay, I'll put a little cross here. You should not do this. Don't write it like that. Some of you would write 4, all right, multiply by a plus 3. Now, we can't do this because a plus 3 belongs to one entity on its own, okay? Now, if we don't put the brackets, this is how it's going to look like, because we know that when we do numbers, when it comes to the order of operations of numbers, we always do multiplication first. So that means that if we don't put the brackets, we have to do the multiplications first, which is 4 times a, which gives me 4a. And we're going to add 3 to this. Now, this will significantly change the area as compared to this. Now, I'll show you how to simplify what is 4 multiplied by a plus 3. I'll show you what is the correct answer for this, because I'm going to show you like 2 different ways of how we can actually do the multiplication of 4 multiplied by a plus 3. So please do follow this really important part of the lesson. Okay? Now, so what we're going to do with this is we're going to be looking at when we do 4 multiplied by a plus 3. I'm going to show you with a little diagram first, okay? With, again, a little rectangle here. Now, we do know that a plus 3, I can actually divide this into 2 little parts here. I'm going to divide this rectangle into 2 parts. Not the same parts, but instead of having this entire length to be a plus 3, I'm going to call this to be a, and I'm going to call this to be 3. Why do I do that? Is because when I add both of these up, it's going to give me a plus 3. Now, I know the width of the rectangle, or the breadth, is going to be 4. Okay? So which means, if I want to find this area, I know this would be 4 as well. Now, let's look at the first part of this rectangle. What is the area of this rectangle? If we take a times 4, that's going to give me 4a. Okay? Because a times 4 is basically taking A and you add A 4 times. So it's A plus A plus A plus A. And that's going to give me 4A. Okay? Now, the next thing we're looking at is what is 3 times 4. So 3 times 4, that's going to give me 12. So what is the total area of this whole rectangle? It's going to be 4A plus 12. Okay? And that's going to give me the area of the rectangle. And if you compare to this, do they look the same? Of course they don't look the same. Okay? So if they don't look the same, then we have to basically not do this. All right, but I want to show you another way where we can actually get 4A plus 12 in a much more efficient way. So if you don't like to draw the rectangles, there is another way to do this. Now, if we do 4A plus 3, okay, there's a very nice little efficient way that we usually do. And we tend to deviate away from the diagrams as we get used to how we could multiply a number to an algebraic expression. So what we could do is, if you want to get 4A plus 12, this is something what we call using the distributive property, which is actually very helpful. And what we do is basically we take this number, which is 4, we first multiply this to A first. Okay, so we know that 4 times A is just simply 4A, like we just said. Now, what you would do next is you're going to take the same number, which is 4, and you're going to multiply by 3. Now, not forgetting we got a plus sign here, so I'm going to put the plus sign here. And 4 times 3, that's going to give me 12. All right, so I would say if you get 4A plus 12, and if you compare to this answer, that would be the exact same answers here. Now, I'll show you another illustration here, another example here. Now, if you're going to have 8 multiplied by A minus 5, okay? Can we do that again with this distributive property? We could do the same thing. We could do what is A times A. All right, that's step number 1. That gives me 8A. Now, because there's a minus sign, we're going to put the minus sign here. Then we're going to do step number 2. We're going to do 8 times 5. And that's going to give me 40. Okay? Now, again, if you want to draw the diagram, you could easily do the same thing. Okay? I'll divide these two rectangles into like 2 little parts here. Now, we know that one of it has to be 8. Okay? So, I can call this to be... this whole thing to be 8 if I want to. And A minus 5, I'm going to put A here, and I'm going to put minus 5 here, because when you add these two up, it's going to give me A minus 5. All right, then what you need to do is basically, oops, sorry, did I just draw an extra line? Let me just draw the rectangle again. There shouldn't be another line in the middle. So it's going to look something like that instead. So let me redraw this again. So this would be 8, then this would be A, and this would be negative 5. Okay, again, it doesn't matter what A is. A could have been a number which is like 10, 20, 30, it doesn't matter, but because we want it to be abstract, so we're just going to call that A for now. Okay, so we're going to do the same thing again. We're going to find the area of this rectangle. And we know that this would be 8 because these two sides have the same dimensions. So if I take A times 8, that gives me 8A, okay? And if I take negative 5 times 8, which is negative 5 times 8, and that's going to give me negative 40. And all you really need to do is just combine these two things. That will give you the area of the rectangle, which is 8A, all right, minus 40. Okay, and that will give you the area, which gives you the same answer as this. So of course you could choose whichever way that works for you, to see which, because some people just work better when they do have a diagram or something like that. Okay, now my last example I want to show you is, does it matter if I only have 2 terms in the brackets? Okay, so example 3, let's look at this one. What if you have something like that? let's say if you have, let's make it even more complicated now. Let's make it more complex. Let's have like -2. Let's have a. Let's have plus b. Let's have plus 4. Let's make it as complicated as possible. Does it make any difference? No. The good news is we could still use both ways to help us solve this. Now, if you like the distributive property, we could take -2 times a first. That's step number 1. -2 times a is just going to give me -2a. Then I'm going to take -2 multiplied by b. Okay, so -2 times b obviously is just -2b. Okay, so I'm going to put minus 2b here because a negative number times a positive term is going to give me a negative term. Okay, and lastly we're going to do step number 3, which is -2 times 4. All right, -2 times 4, that's going to give me -8. So I'll put minus 8 here. Okay, now again, if you don't like this method where you might think this is a bit too complex, let's try to draw a little rectangle here again. Now, but in this case, we're not going to have only 2 parts to it because this has 3 parts to it. So I probably would have to draw like 3 parts to this. 1, 2, so I'm going to call this A, I'm going to call this B because they are all positive, and I'm going to call this 4. Because when you add all these up, it's going to give me A plus B plus 4. I'm just going to call this -2. Now, I know you might argue saying that the width can't be a negative number. Well, you do have a point here. But again, the same methodology could be used again if you want to find the area of this rectangle here. Okay, so let me just show you how this works. If you take, this is -2 as well. If I take A times -2, A times -2, that's going to give me -2a. The good thing is when you multiply a number to a term, you can just combine everything together. Okay, which is -2a. Then this one is going to be b times -2. That's going to give me -2b. And 4 times -2, that's going to give me -8. Okay, and again, if you put everything together, which is this answer, and this answer, it's going to be -2a minus 2b minus 8. You just literally combine everything together. And that's how you get the answer to look the same as this. All right, hopefully this quick tutorial helps you to be able to expand or multiply with what we call a single bracket. When I have the time, I'm going to make a video of how we could do it with double brackets. Now, what double brackets could mean would look something like this, which is taking like a plus b multiplied by a minus b, something like that. This is where you have like double brackets. So I'm going to make a video on this shortly, but hopefully you do understand how the single brackets actually work and how you could multiply a number to an algebraic expression. And hopefully with these 2 ways, you could choose the best way that would be the most suitable for your own learning. All right, if you like this video, hit the like button, and I'll see you guys very soon. Take care, guys.